Welcome in session 93E from the well-known Little Mobile Studio 11, where we continue our study of the bubble sort. And we have to answer those two questions. So let's start with the first one with A. So if we consider this being the correct bubble sort algorithm, and that is the case, as we will see later on, then we see that we have two for loops where as we take an array integer, let's take an example, why not? Let's take a being the array, and I will write it like this for short, being the array 2, 5, 3, minus 1, 5, or 51. Let's say like that 1, 2, 3, 4, 5, 6. So 6 elements. Then you will see that in the outer for loop, and you know a for loop goes on and on. With the while loop, you can think of every time you pass that you have to look for the condition to being true or not, because it can change from within the loop. I agree that is also the case if you want for a for loop in the more evolved programming languages. But the purpose of a for loop is to go through it all the way. So that's to say from the bottom, the lower limit to the upper limit. And the upper limit here, including, it's including, so it must be performed also for this value, is n minus 2. So that means if your counter I starts at 0, it will go next time to 1, go to 2, to 3, and in our case it will stop at n minus 2, so that means at 4, actually performing also at 4. Now let's move a bit further and let's say, okay, we're not going to take 6, but we're going to take a value n, yeah? So then we go further and further and we will come to n minus 4, let's say, n minus 3, and then n minus 2, it stops. N minus 3 being in our example 6. You could say, okay, but you don't have then n minus 3 and n minus 4. Yes, I have them, because n minus 3 would be then, in that case, 6 minus 3 is 3. That would be this value, and 6 minus 4 would be this value. But now I have enlarged my scope, let's say, to say that I will go from the counter E, at least will go from 0 up and including to n minus 2. And what will the other counter J do? So every time you go in the for loop, in the outer for loop, you will instigate or start a second for loop, and that will go how? Well, the value J will go from n minus 1, and n minus 1 will not change. So every time you go in the for loop, you will start at n minus 1. So that means at 5 in our example, but let's not broaden our scope and say, okay, that is n minus 1. And we'll go down to and including I plus 1. So the first time you go through that loop, you go to the value 0 plus 1, so being 1. So you go n minus 1 up and down to the value 1 through that inner loop with the counter J. So how many times is that then? Well, the first time, watch out, we can look at it from left to right, that's true, but we can also add up and go from right to left. So 1, 2, and so on, 3. So I hope you see I go how many times through the inner loop? N minus 1 times. 1, 2, 3. Let's say that I have value 6, then I have to write here 5, yeah, n minus 1, 6 minus 1. So I go 1, 2, 3, 4, 5 times through that loop. The second time I will be 1. So I start again at n minus 1, but I will go to I plus 1, I being 1, so up until 2. And which means, what does that mean? Maybe I should write it like this. Maybe it's better for you if I write it like this, yeah? Then you can see if this is n minus 1 times, then this, okay, that's 1 time less, so that's n minus 2 times. I hope you see that, yeah? Try to find it out if you don't see it with the value 6, because now I go on. Because the third time already, so the second, with value 2, but it's the third time already, I start with n minus 1, and I will go to value 3, and that means that I will go through that loop n minus 3 times. and so on. I will do it once again here, n minus 1 up until 4. I hope you see it, and it will be n minus 4. So every time I go through the loop, if the value of I is 0, I will start at 1. If the value of I is 1, I will start at 2. If the value is, and so on, blah, 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 will 4. So that means if I'm coming at the end here, that my loop will go from, and my j value will go from n minus 1 up until n minus 4 plus 1. I hope you see it. Every time it's plus 1. So here it will go from n minus 1 up until n minus 2 already, because I have here that this is together minus 3. I hope you see that. And then the last time I will go from n minus 1 to n minus, am I right, n minus, now I must do it correct, so n minus 4. Oh, I have, no, just a minute. Yeah, it's correct there, what is written there. So for n minus 1 up until n minus 2, coming from here, plus 1, so up until n minus 1. That means that you will go through the loop one time, because n minus 1 will not be greater than n minus 1, yeah? So we will go one time through the loop, and then that's already an answer to the following question, because that means that this, at the end, you go one time through the loop. Here, in not the one but last case, you will go 2 times through the loop, and here I hope you see it. Otherwise, look at it more thoroughly. You will go 3 times through the loop, and so on. So you start at 1, 2, 3, 4, 5, 6, 7, 11, and so on. Depending, of course, on the value of n, but in general, we don't know which value that is. We only know that it's a natural number. So we will go through the inner loop one time, plus 2 times, second time, plus 3 times, third time, plus 4 times, and 4, plus 5 times, and so on, plus at the end, n minus 4 times, plus n minus 3 times, plus n minus 2 times, plus n minus 1 time. That's the last one, that's this one, yeah, I hope you see it. But this we can write otherwise. Maybe some of you see it already, but we can write it as follows. We can write it as a summation sign. I hope you know that. Otherwise, you have to look on the internet and Google in considering summation signs, because we can write it as follows. Yeah, a counter. Let's call it another value. They give it another value, because otherwise you might think it's the I coming from here, and that's not really the case. So we take a value k, which is going from 1 until n minus 1, up until n k, and this is actually the times that the inner loop will be performed. But what can we say about this? Well, we can say a lot about this, and that's thanks to the greatest mathematician of all times, namely Gauss, who wrote, otherwise look it up on the internet, who found, when he was a young boy already, some of natural numbers formulas, natural numbers formulas, and one of those, the simplest of them all, sum of natural formulas, and he said, a couple of 100 years ago, he said, well, I know how much that is. If you consider that the upper limit is n minus 1, then it will be n minus 1 times n divided by 2. This is actually, you can control it and check it out, and you will see that it's true, the times that the inner loop will be performed. But we can write this also otherwise. We can write this as follows. We can, for starters, we can, the brackets or the parentheses, we can calculate them or try to take them away. So we have then n square minus n divided by 2, and then we can write it again as follows. I'm writing in red, I don't know why, but anyway, let's continue now. We can write it as follows, namely n square divided by 2 minus, I have to write minus here, my fault, minus n divided by 2. But what can we say about this? Well, this is the so-called leading term. This is the leading term, yeah, the leading term. What does that mean? Well, the leading term is the most important when you consider n, and that's what we are doing, going to always increasing, going to infinity, always getting bigger and bigger. We call it asymptotic analysis. Asymptotic analysis. That means asymptotic analysis. That is what we are trying to perform, analysis. That is what we are performing. So that means if n is big enough, then you don't have to consider the second term anymore. It will it will vanish. It will be nothing if you take, for instance, a value 1 billion, for instance. Here you have 1 billion square, yeah? It's much more than 1 billion. I hope you understand that. So this in asymptotic values or in asymptotic thoughts can be left out. Even the divided by 2 can left out, because that also when you are increasing the n value all the time through, then the divided by 2, that doesn't mean anything. So, and therefore for that situation we have a notation. Look at the internet, there are a lot of notations, but one notation that you can follow is the theta, so-called theta notation. The theta notation. And the theta notation is saying, okay, notation, on in general, notation, in general, we can say that the that the that the order of magnitude, order of magnitude, we call it like that, order of magnitude, concerning the times, the time complexity, so the times that inner loop is been going through, will be quadratic. Will be this term, this part of your expression for your time complexity. So that is what the big conclusion. So we can write it more officially, maybe. So the time complexity of the bubble sort concerning the magnitude of your problem, and the how many elements you find in your array, is of order of magnitude square. That is what we can conclude here. A lot of things to consider here. This is the first part of the bubble sort. I think it has been long enough. So the second part of that problem that we have to tackle, we will do that in the next session.